Awesome. Okay, learning the discipline. Draw your gig icon. Draw your lips. These are the vocab that we need to know. And there's only one, and it's called solution of an inequality. Solution of an inequality. Is that hard to read? Solution of an inequality. What does that mean? It's any number that makes an inequality true. Any number that makes an inequality true. So if I said x is greater than 3, the solutions are all the numbers that are greater than 3. Any number that makes that statement true. So you will also have to know the difference between an open circle and a shaded closed circle. Okay, an open circle, okay, is going to mean that something is greater than or less than. Or less than or greater than. A closed circle is going to mean that it is less than or equal to, or that it is greater than or equal to. So closed circle means it includes that number. If I said x is greater than 3, it's all the numbers that are greater than 3. If I said x is greater than or equal to 3, it's 3 plus all the numbers that are greater than 3. So it includes that number. And I want you to write yourself a little note here on the side. Okay. The sign points in the direction of the arrow. So you'll see that when we get to the graph, whatever the arrow points to, if it's a greater than sign, you're going to shade in the direction of the arrow. It tells you which way to shade. The sign points to the direction of the arrow, and you know that's where you're going to shade. Pencil up when you have that. Beautiful. All right, let's move on to modeling. So we're going to go on to example 1 here, okay? Example 1 is going to have a couple parts. So I want you to put EX for example 1. Either circle it or box it, whatever you want to do. Example 1. You might get a question that asks you, is the given number a solution? Is the given number a solution to the inequality? Is the given number a solution to the inequality? Okay, and this is what they give us. They give us x times the quantity of, n minus 6 is greater than or equal to negative 4. So they're going to give us different numbers. We're going to have to plug it in and see is the solution true or not, yes or no. Okay? So let's look at the first one. So this is going to be part A, first problem. They're going to ask you, does the number 3 work in that? Okay, so the first thing we're going to do is substitute the number 3 in there. Okay, so I'm going to have 3 times the quantity of 3 minus 6 is greater than or equal to negative 4. I'm plugging it in for n over there. So your step 1 is to substitute. Substitute that number in. And step 2, we need to simplify. Simplify, okay? So I'm going to do parentheses first. Please excuse my dear Aunt Sally, order of operations. So I have 3 times 3 minus 6 is negative 3. It's greater than or equal to negative 4. So I simplified my parentheses first. Okay, now I see that I have multiplication on this side. 3 times a negative 3 is negative 9. Is greater than or equal to negative 4. So we just did step number 2, which was simplify. And when you simplify, you got to use PEMDAS, right? Order of operations. So now I'm going to look at that and say, is negative 9 greater than or equal to negative 4? No. So my answer is no. That's it. Bam. Done. No is the answer. Remember, it's important to write down every step that I do so that when you get to the test, you have to show your work for that point. You know exactly what to do. Okay? Let's try letter B. They want us to substitute in negative 2 into that same equation. So remember, the equation is n times n minus 6 is greater than or equal to negative 4. So our first thing we have to do is substitute. All right, so let's put that negative 2 in there. Negative 2 times negative 2 minus 6 is greater than or equal to negative 4. I plug negative 2 in for n. Okay, then I'm going to simplify parentheses first. Negative 2 times negative 2 minus 6. Same signs, add and keep the sign as a negative 8. It's greater than or equal to negative 4. So I'm taking each step down. Now I'm multiplying. Negative 2 times negative 8 is positive. Negative times a negative is a positive 16 is greater than or equal to negative 4. Now to think to myself, is 16 greater than or equal to negative 4? Is it greater than?
Yes.
Yeah. So the answer is yes. It's greater than or equal to. So again, we plugged it in by substituting, simplified, and came up with either yes or no. Is it greater than or equal to? One or the other. It's not greater than and equal to, so don't get that confused. One or the other. Okay, last one for example 1. They want us to insert 5. They want us to insert the number 5. So again, the equation is n times n minus 6 is greater than or equal to negative 4. So the first thing I'm going to do is I'm going to substitute 5 in for n. So 5 times 5 minus 6 is greater than or equal to negative 4. Then I do the parentheses first. 5 minus negative 6 is negative 1. Sorry, 5 minus 6 is negative 1. Is greater than or equal to negative 4. 5 times negative 1 is negative 5. Is greater than or equal to negative 4. Is negative 5 greater than negative 4? No. Is it equal to negative 4? No. So that's not a solution to the problem. No is your answer. No. All you do is write no. Hands on your head if you're comfortable with that. Bam. We're good. All right, then we have the easy example out of the way. Let's try example 2, which is probably going to be just as easy for you, because you've seen this before. You're going to get different types of problems tonight, okay? These directions say to write the inequality for the graph. So this time they're going to give you a graph, and you have to determine what the inequality is by looking at the information. Okay, for example, let's look at letter A here. You might get a graph that looks like this. Draw the graph, please, in your notes. Can you guys please draw that in your notes? So the first step is we need a variable. So we're going to say x. All right? So let's identify x. That's step 1. Now we need to examine if it's a closed circle that's filled in or if it's an open circle. It's a closed circle, so I know it's going to be something or equal to. Now the arrow is shaded to the right. Now the direction that the arrow faces, it says that it's greater than, all the numbers greater than -3. So it's greater than, it's a closed circle, so it's or equal to, and the number that is identified is -3. That's it. Okay, so let's look at it. Step number 1. You identify x. You can call it s, you can call it t, but let's just call it x. That's step 1. And step 2, you have to examine whether it's an open circle or closed circle. Open or closed circle. And that'll tell you if it's greater than or less than or equal to. So again, looking at the graph, the number we see is -3. X is our variable. It's shaded to the right, which means it's all the numbers greater than. And if it's a closed circle, we have to put the or equal to sign there. If it's an open circle, you don't need that line underneath. Okay? Let's look at B. Draw this graph in your notes. Alright, so draw that graph in your notes. Now looking back at the steps, we need to identify x. So x is something, a number. Now it's shaded to the left, so that means all the numbers that are less than, so I'm going to put the less than sign, they're going to be less than 15. Now, it's an open circle, so it's not or equal to. It doesn't include the number 15, so I don't need that line underneath. Therefore, I am done. That graph tells me that something, x, all the numbers that are shaded, are less than 15. So again, it's easy to know the greater than or less than sign by seeing which way it's shaded. Easy enough? Hands in your head if you, that one's easy too. Okay, great. All right, example 3, different type of problem. These directions tell you now you have to graph the inequality. So go ahead and write graph, write the directions down. The inequality. Graph the inequality. So here's our first one. Y is less than or equal to 10. Okay, first thing we're going to do is draw the graph. Draw a graph. That's step 1. Draw a graph. Step number 2, we need to place the number, whatever number they give us in the problem, on the graph. Place the number on the graph. Place the number on the graph. So I'm going to go to the graph. Doesn't matter where you pick it. I'm going to go right here. I'm going to put the number 10 because that's the number they gave us in the problem. Place the number on the graph. Now step 3 is we need to determine whether it's going to be an open or closed circle. So identify or determine if it's open or shaded closed. Identify if it's open or closed circle. Now we know closed circle means it has to be or equal to. It includes that number. Open circle means it doesn't include that number. So let's look back. Does it say or equal to? Yes, it does. So I know it's going to be a closed circle because it's going to include the number 10. It's or equal to. It includes the number 10. Last thing I need to do, step number 4, is shade in the direction of the sign. Shade in the direction of the sign. Shade in the direction of the sign. So I want you to think of the sign as an arrow, right? If my sign over here is like this, I'm going to think of it as an arrow. That means I'm going to shade left. Think of it as an arrow, shade the left side of the graph, and then your graph is complete. So again, think of the sign as an arrow, a bow and arrow. It tells you which way to shade. I'm shading left. Are you good at that? Yes? Hands on your head if I can move my paper. Okay. Moving paper. Okay, let's try one more. Let's see. -4. This one's going to be not tricky, but you have to pay attention. Is less than W. Most of us are going to say, okay, I'm going to plot the -4 and shade left. No. Put the variable first. So W, I'm going to rewrite this, is greater than -4. If I were to put the variable first, see how the open part of the sign is facing the W? That actually means I'm going to be shading right. So you got to pay attention. Write the variable first. Okay, so again, step 1, draw the graph. Step 2, put the number on the graph. I'm going to pick right here, -4. That's the number they gave us. Step 3, is it going to be an open circle or a closed circle? Well, it doesn't have that line underneath that tells me we're equal to, so it's going to be an open circle. And last step, shade in the direction of the sign. If this was a bow and arrow, boing, I would be shading to the right. Shade, 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 and then you're done. So remember, on your homework or on your guided independent practice, if you see the number first, switch it to the variables first. Okay. Okay, last type of example. Example 4. It says define a variable. That means find the variable x, if you want it to be, and write, define a variable, and write an inequality to model the given situation. Ooh, when it says situation, I know that they're going to ask it to me in word form. Not with numbers, words. Define a variable and write the inequality to model the given situation. So they're going to give you a sentence, some sort of situation, and you have to describe what it looks like using those signs. For example, here's letter A. The temperature in a refrigerator, a refrigerated truck. The temperature in a refrigerated, make sure you're writing it down, truck must be kept at or below 38 degrees Fahrenheit. The temperature in a refrigerated truck must be kept at or below 38 degrees Fahrenheit. And we love word problems because we can find things in there that help us identify what you're right. It's easy. We can do that. So I know in my word problem that it's important for me to know the number. So 38 is going to be our number. Right there. I also know that I need to figure out if it's going to be greater than, less than, or equal to. Well, it says it's kept at, which means at a certain temperature, so at 38 degrees, or below it. The word below, I know means, less than, less than. So if I were to think out my problem, I would say, okay, it cannot be above 38 degrees, because it says below. We know that. It cannot be above 38 degrees. But it can be 38 degrees, because it says at, or below. I know that means less than. Now, it says define a variable, so I'm going to pick T since it's temperature. So my variable, I'm going to say temperature is going to be T. You can make it anything you want. I'm going to pick the letter T for mine. So now I know T, I have the number 38. Now let's see, it cannot be above, it has to be below, so I know it's going to be less than. But it says it can be at 38, that's or equal to. It can be 38. So then I write my equal to sign. And that's it. So you just have to look at the word problem, identify your number, identify which way the sign's going to go, and see if it's going to be that or equal to. One more, and then we're good. Okay, let's look at one more. The Navy's flying squad, their name is Blue Angels. The Navy's flying squad, the Blue Angels, bless you, make more than 75 appearances. That's a lot of appearances. Each year. So I mean, they go to 75 different places to make appearances with their flying materials, right? So going back and looking at that word problem, I know that 75 is the number I need. And my keyword is more. More I know means greater than. So more than. And there's nothing that says at, so that's all I can do. So I know in my head, if I jot it down, it can't be 75. There is no at. It's not at 75, it's anything more. So it can't be 75. But it does say more than 75. So let's see, I need to figure out appearances. What am I going to choose for my variable? I'm going to say appearances will be the letter A. Why not? A for appearances. So A is my variable. 75 is my number. I just need to find out what goes in between here, right? So it says more than. I know that that means greater than. There's no at. It can't be 75. So my answer is A is greater than 75. Okay, go ahead and stop the recording. I'll look.